Hey guys, it's Miss Man. This is going to be our video on 1.1 transformation functions. We're going to be taking some points and some different shapes and moving them around the coordinate plane, or just looking at them in general from points and trying to determine where they're going to go and where they might end up, or vice versa. We might start with where they ended up and have to figure out where they came from. So the first few things that we're going to hit with this video: domain and range, identifying from points, identifying them on the graph, find the range given domain, and some different examples with that, and then backwards, find the domain given range. Basically, we know where we ended up. How can we get back to where we started? The first thing we need to talk about for domain is what it might look like. So it might look like a couple of different things, and it can ask you in any form. Given the input, given the pre-image, given a list of points, A 2, 4, B 5, 6, whatever it is, your domain will look like all of these things. Some questions might be like, find the range given the pre-image triangle ABC. Find the range given points A, X, Y, Z. It might also say things like evaluate a given function given either the pre-image, the point, the domain. It might name all of those things. Our range has other names as well. We have the output, the image, basically what we end up with after we take our pre-image and change some things, we get our image, and A prime, XY. So the range, I can always tell a range point if it has the prime, or even double prime in some cases if we did multiple different transformations. Some questions involving range might look like, find the domain if A prime, B prime, C prime looks like this. What is the pre-image if X, Y, and Z? Given the image, find the domain. All of these different things will be indicative of finding each one of those pieces. So, identifying, looking at some examples. So I'm given a graph and I have DEIP, D prime, E prime, I prime, and P prime. We've got to decide which one is the domain and which one is the range. Flipping back just 1 second, if we look at our domain, we have a list of points here, range, and a list of points here, and I notice again the range has this prime attached to it. So if I look here, all of my D prime, E prime, I prime, P prime, I can tell that this blue function here is going to be my range functions. These questions are asking for a list of points. So in this case, I can already tell that my range is going to be our prime values, D prime located at 5, 4, E prime at 2, 3, I prime at 4, 0, and P prime at 5, 0. Our domain has to be the other points, which is going to be the black points, and they are located at these points: D at 1, 4, E 4, 3, I 2, 0, and P 1, 0. So in this case, if it just says identify the domain and range, this is exactly what it's looking for. It wants you to list out those points. You can go ahead and pause the video for a second if you want to and try this example on your own. Try to identify the domain and range. I've kept the colors separate so that you'll actually have to try to guess at it, but hopefully you'll be able to get it on your own. I'll give you 2 seconds if you want to pause the video and try it on your own. All right, were you able to guess? The range is our red values, M prime, C prime, J prime, and K prime at these points, and our domain are the black values, M, C, J, and K. also located at those points. Again, if it's asking for domain and range, that's all it's asking for. It's just a list of values. Okay, so let's getting into actually solving some of these problems, like given this, find this, or evaluate these different kinds of things. The first thing I want you to think about is what information am I given in the problem? And we'll be going through and highlighting some things to help you guys kind of piece that together. Then you need to think, okay, how do I know it is what I think it is? Again, the key thing here, range has the primes, domain doesn't. This is going to help us determine where we go next. If we are given domain first, plug in the points. We can always see this or remember this because domain ends in IN, or think about your input. That's how we can remember to plug in. And then given the range, if that's the first thing that we're given, your A primes, your B primes, we need to set the first equal to the first and the second equal to the second, and then solve. This will make more sense in just a minute. Our first example, evaluate the function f of xy. So we're going to take a point, any point, and put it into this function machine, and we want to do this for point A32. So again, the first thing we want to ask is, what information am I given? So I am given a function, and then I'm given this point right here. Now, we know, given domain, we plug in, given range, set equal, the first equals the first, and the second equals the second. So we need to determine if this A32 is either part of the domain or part of the range. We always know that the range has the primes. There is no prime here, so this is a domain value. So if it's domain, we're going to plug those values in. And we're going to take that function, 2x minus 6, and then y plus 6. We're going to get out a prime. You might have to do it. That's okay. So 2. Now remember, this is our xy. So 2 times 3, we're going to plug that in 6. And then y is 2 plus 6. So this is our bigger point. And we get out our a prime. 2 times 3 is 6. Take away 6 is 0. Using order of operations, and 2 plus 6 gives me 8. So we have successfully evaluated that function. And if I'm given a, I know I have to end up with a prime. We always have both of those points with our problem. This one is very similar. The pre-image P, so it's already telling us it's a pre-image P, was transformed based on the function. So again, this is our function. Find B prime. I'm given B. I know it's in my domain. If it's in the domain, we plug in. So B is at 8, 10. We're going to use our function 3y minus 4, x plus 4. And it's okay that the x and the y's are swapped. Perfectly fine. We have seen with our rotations and reflections that sometimes the y comes first and the x comes second. And that's okay. It just depends on what the function is doing with the point. I'm going to plug in 3y minus 4 and then x plus 4. And then we recall we have xy, and we're going to plug those in their appropriate places. So x in this case is going to go over in the y spot, which is the 8, and then the 10 in the y. And then we just go through and simplify. So b prime, 3 times 10 is 30. Take away 4 is 26. 8 plus 4 is 12. And this is the b prime value that we were asked to find. Sometimes we're given a whole triangle that we're trying to move across a different function. So what we have to do is take each one of those points individually and then move them. So I've already been told find the coordinates of the vertices of triangle A prime, B prime, C prime. So that means I was given the domain. And we know that because triangle ABC and our ABC, AB, and C are all do not have primes. So I'm given the domain, I'm going to plug it into our function and then get out our other values. I've already kind of laid out the work for us. Purple, just for funsies. So the first thing we want to plug in is our X for our A, and then plug in the 4 for the Y. We'll go ahead and plug in the -2 for the X, and the 3 for the Y for B, -10, that's a 10, and then 6 for the Y. Now we can go through and simplify each of those and find our A prime, B prime, and C prime. So -0, that doesn't make any sense. So 0 plus 2 just gives me 2. 4 take away 10 is -6. Negative, negative, or the opposite of -2, you can think of it the same way, is just +2. 3 minus 10 is -7. The opposite of -10, or -10, is just a +10, and then 6 take away 10 is a -4. So find the coordinates of A prime, B prime, and C prime. These are all of those right there. -7. Okay. Sometimes we're given a picture on a graph, and then we're asked to draw the transformed image on the same axis. So first we have to actually transform the function, find the new points, and then we can go back and draw them. It's most helpful if we first find the points that are already there, J, E, M, and T. We're going to take each of those and transform them. If we take J at -3, -2, those are my X and my Y. All of these are domain values, so I'm just going to plug them into their appropriate spots. -3 plus 1 gives me this -2. -2 plus 1 gives me this -1. Then we can go through for E, to find E prime. -1 plus 1 gives me 0. Plug in the -5 for Y. -5 plus 1 is -4. M, 3 and -2. So 3 plus 1 gives me 4. -2 plus 1 gives me -1. And our M prime, 0 plus 1 is 0. -1 plus 1 is 0. I think I said 0 plus 1 is 1. So T prime is 1, 0. Now we can go back. We'll draw it in blue, I suppose. J prime, -2, 1, 2, -1. Then we have, make that a little bit bigger. That was J prime. E prime is 0, -4, 1, 2, 3, 4. M is 4, 1, 2, 3, 4, negative 1. And then T is at 1, 0. And it should have about the same shape as the actual shape. And now it's been transformed using that function that we started out with. And then, as always, you should, as best practice, this was J prime, this was T prime, this is M prime, and this is E prime. Just so that you can communicate using good mathematical skills. Okay. Now we're going to look at another question. Point A was transformed with the function. So I'm given a function. And it became A prime. So now I have this point and a function. Again, is the point the domain or the range? I'm going to look at it. It has A prime. Primes are always in the range. And then we said this funny thing about setting the first equal to the first and the second equal to the second when we were given range first. What that means is I'm going to take the first equation, I'm going to highlight the first equation and set it equal to the first point or the first x or whatever's in the x spot of my point. Then I'm going to take the second part of the function and set it equal to the second spot in my point. Now, we say the first and the first and the second and the second because sometimes, remember, depending on your transformation, your x and your y might be swapped in your transformation function, and that's okay, depending on what exactly the transformation is going on. So you can't always rely on setting x equal to x and y equal to y. It is okay if they are different. So we're going to go through and we're going to start solving this, and I'm going to show you how to set this up. So I'm going to write, let's do blue, and I'll go back and recolor this so this makes a little more sense for you. So we were given the point A prime, and we have this transformation. Now we're going to set equal the first and the first. So that means 8 is equal to 2x minus 6. And then the second equals the second. We'll do that in red. The second equals the second. And then you set that equation off to the side, and then you'll solve them one at a time. So the first equals the first, the second equals the second. Now we can go through and solve. So I'm going to solve like a regular two-step equation. 8 plus 6 is 14, equals to 2x divided by 2. 14 divided by 2 is 7, and that equals our x value. Then for our y, subtract 6. 5 take away 6 is negative 1, and that is our y value. That was the 7. So now it says, what is the coordinate of the pre-image? We can come back and say we started with A prime. So A is at, and then we'll put them back in order, 7, negative 1. And this is the coordinate of our pre-image. So we started with the A prime and we ended up at A. If you start at A, you have to end up at A prime. Okay, another one asked a little bit differently. After a transformation of, so that's my function, point B became B prime 11, negative 6. What were the coordinates of point b. So again, we started with b prime. We're trying to find b. b prime is part of the range. So we want to set the first equal to the first and the second equal to the second. The first equal to the first and the second equal to the second. Again, it is okay that y is first. That doesn't mean that you have to swap them. It's always the first and the second and the second. 11 is going to be equal to 3y minus 4. And then our second equation, negative 6 equals x plus 4. Now we're going to go through and solve each one. I'm going to add 4 to both sides. 11 plus 4 is 15. It's equal to 3y. Get y by itself. 5 is equal to y. I want to get x by itself, so I'm going to subtract. Negative 6 take away 4 is negative 10. And so now we have an x and a y. The order that we got them was not important. First equals the first, the second equals the second. And now our b value that we were trying to find, we're going to reorder them in the correct order. Negative 10, 5, because this was our x and our y. The last example I have for you is now we're going to look at an entire triangle. A prime, B prime, C prime are located. So notice these were all the points that we were given, and we were given a transformation function. I'm looking for the vertices of this triangle. So the thing that we just did with 1 point, we're going to have to do that 3 different times. So to help us out, the first is equal to the first. The second, and that is a negative 1, is equal to the second. So now we need to go through and write that out. And we'll even show it. So 8 first with the first, and the second, negative 1 with this one. Is equal to 2y plus 4. I'm going to go ahead and solve it since I don't have a lot of room. 4 is equal to 2y divided by 2. Y is equal to 2. Then we're going to solve our red. Negative 1 is equal to x minus 3. I'm going to add 3. 3 take away 1 is 2. That is my x. So now to go from a prime, we were looking for our original a value, so our a point for our original pre-image domain value for a prime is 2 for the x, and now 2 for the y. So that is the a coordinate of the triangle ABC. Same thing we just did. Now we have to do it for B, but we'll have to do it twice for that one as well. The first 10 is equal to the first. The second is equal to the second. 10 is equal to 2y plus 4. We'll go through and solve this. 6 equals 2y. Divide by 2, divide by 2. 3 is equal to y. And it's nice because you know you're going to solve the equations at the same time each time. You just have to find the new coordinates based on your previous coordinate. And so this one was -4 is equal to x minus 3. So I'm going to add 3 like I did just before. -4 plus 3 is a -1 equal to x. So now our b is at -1, comma 3. Then the last one blue. The first is equal to the first. The second is equal to the second. -8 is equal to 2y plus 4. Subtract 4. Now I have -12 is equal to 2y. Divide by 2. -6 is equal to y. Now I need 3 equal to x minus 3. Six equals x. So now for c prime, we worked backwards to find our original c value. So c is at 6, -6. And that is how we go from the vertices of the transformed function, a prime, b prime, c prime, and work backwards to find the vertices of the original triangle. I hope that this has been really helpful for you guys. Please, if you have any questions, please come find myself, Miss Jennings, or Miss Jackson, or Miss Lawson. We would love to help you and make sure that you are ready to go for your Unit 1 test.